Hello everyone, today we will solve 94 number problem of CSIRNET June 2019. It's a problem of PDE where they have given us a first order linear partial differential equation and they are asking about the general solution of this equation. Basically we have solved this kind of problem earlier in our videos, so I would request you to go there and check the playlist. You will find this kind of one or two problems there. So let's try to solve this question here in this video and try to find the correct option. This is the given partial differential equation and this equation is of this form: capital P into P plus Q into Q is equal to R, where small p and small q stands for del z del x and del z del y respectively. Okay, now simply you construct Lagrange's auxiliary equation and you are already familiar with that. So we have dx upon capital P, it will be this dy upon capital Q and it is this dz by x square plus y square. Okay, so you have this one in your hand. Now simply take the first two ratio and multiply this first ratio by y and multiply the second ratio by x and then add them. So we are having this kind of thing in our hand and make it equal to the third ratio. After doing some calculation, you will find that z square minus 2xy is equal to some constant, say c1, you are getting, and this is your first relation. Okay, to solve this kind of problem, obviously you need to have two relations in your hand, that the final general solution will be some arbitrary function of these two constants. This will be the general solution. Okay, now to find another relation, all you need to do, just take the multipliers like this way: x minus y and minus z. Okay, and finally you will have x dx minus y dy minus z dz, and this term you will have x square plus xy minus xy minus x square minus y square, and every ratio will be equal to this one. So this one is equal to each ratio, and observe this, from this part you are getting 0. So finally you have d of x square minus y square minus z square is equal to 0. So you have x square minus y square minus z square is equal to c2 as your second relation. Okay, so the general solution will be some arbitrary function of c1 and c2. So you are getting z square minus 2xy comma x square minus y square z square is equal to 0. So this is going to be your general solution, and obviously your second option says the same thing as we have obtained. So second option is correct. Now observe rest of the three options. First option, here they have mentioned that some arbitrary function f of x square plus y square plus z square minus z square minus xy. We will not consider even z square minus xy, but observe that you will never get any relation like this one. From this whole calculation you will never get this kind of relation, isn't it? In fact you are getting this relation, so no question of getting this kind of thing. Thus you will never get first one as your correct option, so it is false. Clear? Similarly, you can easily verify that this kind of relation x plus y plus z is equal to c, some constant. You will never get this kind of thing from the whole calculation. You will never get. So this is also false. That means the third option is false. By the similar kind of logic, you can discard the fourth option as well. So only correct option is option second. Okay.